In this section, we'll walk through a few simple examples to motivate 4 features that entered Fortran in its 90, 95, and 2003 standards. We'll use each feature in section 3 of this JOLT. Here we'll discuss only the most salient aspects of these features, although each has additional motivations and use cases beyond what we'll cover. As points of reference, we'll also make mention of a few similar features in C and C++. First, we'll motivate the use of Fortran's primary scoping mechanism, modules, which entered the language in the Fortran 90 standard and which play a role similar to C++ namespaces. Next, we'll motivate the use of derived types, which function like C structs or C++ classes depending on the setting. Derived types enter the language in Fortran 90. Then we'll motivate type extension, which behaves in many respects like C++ class inheritance. Type extension entered the language in Fortran 2003. Finally, we'll motivate the use of pure procedures, which entered the language in Fortran 95. Now let's take a look at one of the primary motivations for using modules. I mentioned earlier that modules are a scoping mechanism in Fortran, so they define where variables and procedures are known, but they also provide some safety by giving the procedures that are wrapped in a module what Fortran calls an explicit interface, which then allows for the compiler to check at compile time the type, kind, and rank of each argument. We're going to first look at what life was like before we had modules in the language, when all of the procedures that we would write were what we would now call external procedures. I'm going to define a simple procedure that will take an argument and return its square. The argument will be real, as will the square. Now let's imagine we're going to use this procedure from a main program. Except, let's say we have naively decided, instead of passing a real argument, to pass a complex argument. That will have a real part of 2 and an imaginary part of 1. Maybe we're thinking that the square function will give us the modulus squared of that complex number. Now let's compile. And then let's link our 2 source files into an executable. First of all, we notice that the compiler let us compile to begin with, which might be problematic if we think we're passing in the right type, but we're not. Secondly, when we look at the result, we see that we only got the square of the real part. This happened because without an explicit interface, which wrapping the procedure in a module would provide us, the compiler has no way to check whether we're passing the right type.